NetIonic equations are chemical equations, just like the balanced chemical equations you're used to writing, but they only focus on the things that are being changed in the reaction. So 2 things to remember about NetIonic equations. They reflect reality. So if something has a charge in the reaction, it's going to have a charge in the equation. If a reactant is dissociated right before the reaction happens, it's going to show that dissociation. The other thing to remember is, again, only what's changing. That's the focus. Only what's changing. There are 2 ways for things to change. They can change charge. They can change phase. So charge, something might go from uncharged to an ion, neutral to an ion. Something might go from Fe2 plus to Fe3 plus. That change its charge. Phase means solid, liquid, gas, aqueous. Don't forget, when you're trying to write a NetIonic equation, these are the things you want to keep in mind. Is the compound ionic? Will it break apart in aqueous solution to form ions? Remember that covalent things do not break apart in aqueous solution. And when they react, there are no charges with covalent things. No ions in covalent. Also think about whether something has a charge or something doesn't have a charge. If you are talking about copper metal, plain old copper that's in your pipes, no charge there. You would just write copper. If you're talking about copper sulfate, now that's the copper ion, and you would write Cu2 plus or Cu plus or whatever it happens to be. But not everything in a NetIonic equation is ionic. Not everything in a NetIonic equation is charged. That's the one thing you have to remember. Not everything needs a charge. Let me give you some examples. If I'm talking about MgCl2 solid, I would just write it like that, MgCl2 solid. On the other hand, MgCl2 aqueous isn't written like that, because remember what I said about reflecting reality? MgCl2 does not stay together in solution. In solution, what happens is the ionic compound breaks up, which is why it dissolves. It breaks up, and it's what they call solvated. We'll get into that more later. But essentially, the charges are being stabilized by the very polar water molecule. So MgCl2 aqueous in a NetIonic equation gets written as Mg2 plus aqueous plus 2 Cl minuses aqueous, not Cl2 2 minus or anything. There are 2 Cl minuses, and they are aqueous. Next example, magnesium plus water. This is solid magnesium. It has no charge. I know we're used to thinking of, oh, Mg, it's 2 plus. But remember, everything I encounter in the world is neutral. So magnesium solid is just Mg. Don't put a charge on it. And water, of course, is also covalent. Water liquid. Now, when this reacts, it's going to react to form magnesium hydroxide and hydrogen gas. Now, hydrogen gas, don't have to do anything with that. That's not ionic. It's not going to be H plus or anything like that. It's H2 gas. Magnesium hydroxide, aqueous, if you wouldn't actually write it like that, because again, ionic compound in water, you would write Mg2 plus 2OH minus. Remember that polyatomic ions are not going to break apart. They are covalent within themselves. Here's another one. MgCO3 dissociates in water. So that's magnesium carbonate, solid. It's put into the water. We don't have to write water explicitly here. It's not a reactant. That's going to give you magnesium oxide, which is a solid, plus carbon dioxide, which is a gas. There's nothing here that is an ion. So there are no charges. And that's fine. It's still a NetIonic equation.